Okay, so here are the things that are due next time, Wednesday. I forgot to write a practice test. There is no practice test. So, you will not be able to show progress on the practice test. So, maybe I should send out an announcement about that, because we're missing a lot of people. Also, apparently this was like the Slack unit for me. I meant to reorganize this, and I may, to make it look like all your other folders have looked. But I had changed it up with the other ones with spreadsheet projects, where everything was like just out. This is the old format that I had last semester, where it's like tucked within its own new other folder. So if I don't change it, this is the assignments that are due Wednesday. You'll have to open up this like second level folder to get to it. I guess there are no new videos. There are no new videos for this. And it's not that I'm not showing you how to do things, but I think I talk about it in this video right here that I have included as just like part of your lesson. So there are no videos from that one website, but this video is me talking about doing the things you need. Okay. So hopefully, while I'm on here, I'll touch base about this. Hopefully, in preparation for today, you filled this thing out. The version that I printed for you is not in color, but that. And then you watched these two videos that talk about mean, median, mode, standard deviation, and outliers. We're going to talk more about that. Guess while I have this open, let's go back to the folder of things that are due Wednesday. Let me double check real quick. Yes. Everything that I'm going to teach you today in class is also in these optional videos. So if you need to re-hear anything, you might try these if you don't want to mess with watching this ridiculous thing that we're recording. Since you already had to live through it once. And you'll maybe, might be higher quality. Okay, so let's go to page 351. So on the videos that you watched, it talked about a whole bunch of different things, mean, median, mode, all that stuff. But I don't think they talked about mid-range. That's one that kind of fell through the cracks. So I'd like to talk about this. Mid-range is super easy. It's fast. To find the mid-range of something, you take the smallest plus the biggest and divide it by 2. It's essentially the, well, I could use the word average, but average sort of applies to all these things. It's like the mean of just the smallest and the biggest. So if you've got a whole bunch of data, you just take this guy and this guy, and you find the halfway point between those. So, smallest plus biggest divided by 2. So on page 351, they have an example. Find the number halfway between the lowest and highest salaries at Vandelay Industries, including Newman's, that's mid-range. We find all of those on page 348. So this is number 9. So the lowest salary is $20,000. The highest salary is $944,000. Add those, divide by 2. Now when we look on page 348 at those lists of salaries, this mid-range salary is way bigger than everybody's salary except the one dude that's making $944,000. If you look at these salary amounts, $58,000, $65,000, $20,000, $52,000, $51,000, $53,000, $55,000, $50,000. They all are definitely under 100,000. Except for the one that's 944,000. The biggest one is an outlier. It is way far away from all the rest. And even the mid-range is way higher than all the rest. That's how big this outlier is. An outlier will very strongly affect the mid-range. The second video you watched talked about the effects of outliers on the different values. If you have one wacky number, it is really going to change the mid-range. If you have an outlier, one crazy weird number that's far away from all the rest, your mid-range will not do a good job of telling you about what most of the data is like if you have one that's really, really off. So number 10, they're saying, well, what if we exclude the outlier? So ignore that 944,000. Here's our smallest again. Other than that super big one, Let's find the mid-range without the outlier included. The next biggest is 65,000. So when we look at our list of salaries on page 348, 42,500, that comes a lot closer to where we would say most of those salaries are. So number 11, explain why the mid-range isn't very reliable as a measure of central tendency. If we're finding the mean, we add up all the data, divide by how many there are. If you have an outlier, that's going to affect the mean. If you have something that's unusually large compared to the rest of them, that number's in there and it's making everything bigger than it would be without that weird big one. But you do have all the other data in there. The mid-range is even more affected by an outlier because the only two numbers you're looking at is the biggest and the smallest. These middle values do nothing toward the calculation of the mid-range. Like, it is solely dependent on the outside numbers, which is why an outlier will really affect the mid-range. And that's why the mid-range isn't very reliable as a measure of central tendency, number 11, because it's just very strongly affected by an outlier. See what I want to talk about next. Ambiguous averages. Okay, so the next thing I want to talk about is on page 457. Lesson 4.9 is all about how to do all this stuff wrong. What to watch out for when other people are misusing statistics, and then also how to avoid misusing them yourself. So we're in lesson 4.9 for this ambiguous averages section. So we know here's where it might go wrong. The chapter says, there was a time when we all thought the average meant one thing, the result of adding all data values and dividing by how many there are. But we know better now, don't we? When someone uses the term average and making some sort of claim, instead of letting us know which measure of average, mean, median, mode, mid-range, that they're using, it's time to trust no one and be suspicious. We know that the values of these different measures of average sometimes differ quite a lot. People who know that there are several types of average can, without lying, select the one for the data that most lends evidence to support their position. For example, suppose a store owner employs 4 salespeople. The number of years each has been employed by the store is 22. So years employed. And 2 and 2. What's the mean? How would we find that?
You just add up, divide
Mm-hmm. How do we find the median? Dun, 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 dun.
Is it just a big one minus a small one?
That's the range. Keep that in mind. Median is the one where we put them in order. Remember this?
From smallest to largest.
Mm-hmm. So once they're in order, from smallest to largest, what are we looking for next?
Oh, you mark them off on the
Yes, we're looking for the middle. So we could like kind of mark those off and then, oh. So if we have two that are tied for the middle, if we have an even number of data points instead of an odd number, with an odd, we just have one middle and that'll take care of it. But if we have a tie, what do we do in case of a tie? We want to find the halfway point between the two. Mm-hmm. So 2 plus 10 divided by 2. Okay, what is this asking for next? Mode. What's the mode? Mm-hmm. And then finally mid-range. Let's talk about. These are all in years, right? So number 16, if the store owner wanted to advertise the fact that his employees have many years of experience, which one of these do you think he'd use? My employees are very experienced.
Probably the mid-range.
On average, they've worked for me 12 years. Well, yes, I have one guy who's been here 22 and one guy that's been here average 12 years. If instead he wanted to say, I've got a really inexperienced sales crew. Which one would he use? Yeah. I've got more people that work 2 years than anything else. Okay, here's where we get to the fun stuff. Page 354. Page 354, number 1. Take a look at this grouped frequency distribution. Do you recognize it? It's data we talked about last time. Remember talking about the record high temperatures? Kind of feels like it's mocking us today on this cold, wet day. 100 degrees being the lowest. So we've got this list of temperatures. And these numbers do not match the one that we made last week. We kind of talked about that. I made an error. We're just going to pretend that it's right. Okay, so if we have this information, this means that 2 states had their highest temperature ever fall within this range. 8 states had their highest temperature ever fall in this range. 18 had their highest temperature ever fall in this range, and so on. So what if I wanted you to find the mean of this information? What is the mean record high temperature for the United States? Now normally to find mean, we just add them up and divide by how many? There's 50 states. So we just add them up and divide by 50, right? Except, how do you add up 100 to 104? We can't do that, right? We know that 2 of them were somewhere in here, but we don't know exactly what they are. So if we want to find a mean for grouped data, trick we're going to use is to find the midpoint of each range. And that's kind of strongly hinted to you on number 1, because they've created a column for that. So the midpoint here would be 102. Now, how exactly do we find the midpoint? That's what we did here. So 100 plus 104 divided by 2. Here we have 105 plus 109 divided by 2. And so on. Or you could think of it as you're crossing things off until you get to the middle. So now we're just going to pretend that both of these, that somewhere fall in this range, are this number. So we've got two 102s. Just pretending that both of those states were 102. They're somewhere in there. They probably weren't both 102, but they could have been a little lower, could have been a little higher. We're just going to hope that it kind of balances out and count both of these guys as being this midpoint value. We're going to count all 8 of these as being this 107 value. So that'd be 102 plus 102 plus 107 plus 107 plus 107 plus 107 plus 107. 8 of those. 18 of those. So I could do I want 8 of those. And I could write them all out. But wouldn't it just be easier to say, oh, well, I've got 2 102s. I've got 8 107s. 18 112s. 13 117s. 7 122s. 1 127 and 1 132. Then how many do we have total? Now this is frequency, so that means there's 2 of them here, 8 of them here, 18 here. Feels like we do this action a lot, where we have 2 columns of things and we multiply everything in those columns and then add them all up. Feel like we do this a lot? We did that with expected value. We took the value times the probability for each row and we added them all up. We don't want to forget at the end we need to divide by the total because we're finding the mean. So if we knew exactly what these temperatures were, we would add up each temperature and divide by 50 because there's 50 states. Just based on this chart, we don't know exactly what they are, but we're just gonna make everything in here be that number. Still, there's 50 states. This represents 2 different states. This represents 8 different states. Add up all 50 states, divide by 50. Okay, so that is mean for grouped data. Next, we want to talk about a weighted mean. So most likely on your test, you will have a problem that asks you to find the mean for group data, or possibly the weighted mean, what we're about to do. So you need to be able to do a problem like one of these two. So if you're still iffy on it, that's why I have a video of me doing these examples again online. You can just go really slowly, make sure you really know what you're doing. So this is page 355. I have a slide for this. Save time. Theoretically. The computer isn't too slow. Okay, this is all in your book. So this kid, Tong, is in a class where on the syllabus the teacher says your homework is worth 50 points total. Your tests are worth 30 points each. Your final exam is worth 50 points. Group work is worth 20 points each, and attendance is 10 points. So, there's a total of 250 points possible in this course. Then we have how this student did. He got a homework average of 87%. Here are his 4 test grades, his final exam grade, his group work grade, and his attendance. To find the weighted mean, we take what he got and we multiply it times the weight. And then we add them all up and divide by the total. Just like this. This once again. 4. No, 355. So we take the score times the weight for each. Add all those things up. So in this case, he got an 87. That's worth 50 total. Plus a 91, which is worth 30 total. Plus an 82. Or you could think of it as he earned 87% of these 50 points. He earned 91% of these 30 points total. You could think of it like that. He earned 86% of 30 points total. Okay, I'm at the 94. There's his grade from the class.
Where did you get the 250
Total number of points possible. So in this case, it's 250 points. Now when we're talking about a grade, sometimes we talk about it like, oh, they got an 87. It's actually 87%, so you could think of it instead as being 0.87. If we made all these percentages be decimals, you just need to be consistent. And then your answer would have the decimal right here. So whichever way you go, if you just keep it 87, 91, 82, 96, if you just keep it like that, then your answer is also going to be like that. But if you say, oh, it's percent, I need to make this actually 0.87, 0.91, 0.82. If you do it that way, just be consistent through the whole problem, and your answer will be consistent with that too. You'd get 0.8872. Weighted mean problems could look like this. They might look a little different. I've got the exact same student, exact same situation. But what if the teacher just expressed things differently? Let's say the teacher didn't want to change up anything. They liked how much tests were worth. They liked how much homework was worth. But instead, on the syllabus, instead of saying, homework is worth 50 points out of 250. Tests are each worth 30 points out of 250. What if instead they did, well, 50 out of 250 is 20%. Those 30 points out of the 250 is 12%. So that would be another way the teacher might be able to say the exact same thing. Instead of putting it all in terms of points, they could just say, well, out of 100% of your grade, 20% of it is homework. And that's true up here too, because 50 points out of 250 points is 20%. So even though these numbers look different, all of these weights add up to 250 in exactly the same proportions. All of these percentages add up to 100%, just in the same proportions here. So we would expect that if we did this problem, this times this, this times this, this times this, just like we did here. This times this, this times this, this times this. Take this column times this column, add them all up. Here, this column times this column, add them all up. Divide by the total, which in this case is 100%, or if you change things to decimals, it'd be 1. Either way, so here it is with points, 50, 30, 30, 30, 30, so on. Here it is with percentages, 20, 12, 12, 12, and so on. Divide by the 250 points worth total, divide by the 100% total. We still get the same grade. The reason I'm showing you this different way is that I want you to be flexible enough to know that the weight could be points, the weight could be percentages, the weight could be dollars, it could be whatever. It's kind of like expected value. Your value could be money, it could be points, it could be birds that smash into a window. Whatever you're counting in, you still do it the same way. Take the score times the weight. Add them all up, divide by the total. Just like we did here. We took the frequency times the midpoint, add them all up, divide by the total. These are really the same steps. Okay, let's talk about standard deviation. These two pictures of dogs are scanned from your book on page 365. They tell us how much each dog weighs, I think on the next page. I've kind of just summarized it here. Here I have 4 dogs. Here we have 8 dogs. We've got 4 medium-sized dogs right here. Their mean weight is 65.25 pounds. Here, I have 8 dogs that range from a really big one to a really small one, a couple small ones. Their mean weight is 64 pounds. So this group of dogs and this group of dogs have a mean weight that's pretty stinking close. But the two groups are really different. If you're going to make Halloween costumes for these dogs, you could pretty much make 4 of all the same medium size and it would fit them all just great, wouldn't it? But if you were to make a medium-sized costume for these dogs, it would be way too little for this guy and super big for these guys. How many of you have ever dressed up your pet for Halloween?
Oh my gosh, I just bought my dog. No,
What is your dog going to be for Halloween?
French fries. I got him this little thing and it's like a box of French fries, and it's got French fries sticking out the top, and it sits on his back, and it like straps around his neck and around his belly.
I bet he's gonna love it.
Oh, it's fantastic. I'll show you a picture of it.
You do that.
He
Um,
loves it.
That's awesome. It's the kind of thing you do before you have kids.
It was on sale for $10 at PetSmart, so I had to buy
Why
it.
not?
It was that or a gnome or a mermaid. It's boy, so I can't really do mermaid.
Be a merman, a mer dog. Merman dog? I don't know. Way to go with the fries. So when we're talking about describing groups, and you saw this in your video, we have things like standard deviation and range that talk about measures of variation, like how spread out is our data. The range here is 15. That means that from the smallest to the biggest, it's only a 15-pound difference. Whereas here, from smallest to biggest, it's a 95-pound difference. The range is much bigger. Another piece of information that can help us know how spread out it is the standard deviation. The standard deviation of this sample of dogs is 7.4 pounds. For this one, it's 30.7 pounds. Standard deviation, just layman's terms, is on average how far away is each dog from the mean. On average, these dogs, give or take, only about 7.4 pounds off of this mean. Whereas here, on average, these dogs are 30.7 pounds off of this mean weight. I mean, you've got this mean, but they're not all like the mean. On average, they're 30.7 pounds off from the mean, either bigger or smaller. That's standard deviation. I should note that there are actually two types of standard deviation. There's a sample standard deviation and a population standard deviation. Unless your problem tells you specifically to do population, just assume we always want sample standard deviation. Those two words come from, remember, population is everybody and sample is like a collection. Well, we're almost always just dealing with a collection. So we're almost always going to be doing sample standard deviation in our group. Now, the mean, median, mode, mid-range, regular range, all of those things you need to be able to do. You need to be able to, like if I gave you a list, you need to be able to find those things by hand or with a calculator. Standard deviation takes a long time. I'm not going to make you do that by hand, but you do need to be able to use some sort of technology to find it, like a spreadsheet, and you need to be able to interpret what we mean when we're talking about a standard deviation. So, let's see. In your homework, if you want to know how to do standard deviation by hand, you could go to page 368. Actually, I think it starts on 367. And the next several page walks you through finding it. So like on page 373, for questions 6 through 8, identify the data set that is likely to have a larger standard deviation. A larger standard deviation means that the data points on average are how far away they are from the mean. So the bigger the standard deviation, the more spread out your data is. So number 6, we've got data set 1 that has numbers 12, 15, 13, 10, 16, 13, 12, 13. They're all in the teens. Whereas data set 2 has 5, 26, 31, 2. It's more spread out.
My book looks weird on the first one.
Oh,
It's not like that. I don't even know what it is. I can't even read that number.
so some sort of weird
It's
inky
like,
blotch.
it looks like 11 and 52 like smashed together.
Weird. Anyway, data set 2 is way more spread out. You've got bigger numbers and smaller numbers. That's a bigger standard deviation. If you look at data set, or at question number 7, if you're looking at how long it takes running backs in the NFL to run 40 yards, and you compare all those times with each other and find an average, versus all of us in here, which one do you think would be a bigger standard deviation? I guess the question is, how close do we think our 40-yard dashes would be? If they were going to be really close together, then they would all have to be pretty terrible, because I would be pretty terrible. But assuming, like, if you have a whole bunch of amateurs, you know, some of you might be athletes, and some of us might be really not athletes. So we probably have, more likely, a bigger standard deviation. Whereas, if you're a running back in the NFL, yeah, there might be one that's faster than the other, but they're all probably really fast and fairly close together in speed. Like, that's what they do professionally. So their standard deviation is probably smaller. Let's talk about finding these things on Excel. I don't even know. Blank workbook, there we go. Okay, so let's go with this first set of data here. Scooch that over. Maybe make this smaller. Perfect, okay. So 70, 73, 58, and 60. Let's turn it a certain color, so let's see. What can you guys see? You can see that. Okay, so that's our data. Okay, if I want to find the mean, in order to get Excel to use a function, I need to start by pressing equals. And you can go to the formulas page, and I could go through and sort of just hunt for these, let's see, recently used. It's probably where I'm going to find what I need. This first one, auto sum, those are common used ones. I don't know that we'd want financial. This little book with the dots, I don't know if you can see that, is like all the catch-all for everything that doesn't fit on the screen. So then if I go to statistical, then I can find a whole bunch of things that are going to have to do with statistics. If you want mean, on Excel at least, you should choose the function that's called average. I'm not totally sure on Google Sheets if it's also called average. See if we can get that to focus in. I want to find the mean of those 4. Press enter. There it is. Great, it matches. If I want to find the range, The range is how far apart they are, so I just need to take the biggest minus the smallest. So I'm gonna go equals biggest in spreadsheet words is called max. So I want the maximum. No. Apparently I clicked on too many things. Okay. Okay. Oh, I have the wrong thing selected. Okay. Equals max, that thing, of those numbers. I close the parenthesis, nope, I'm gonna press shift, and I close the parenthesis. Max minus min, biggest minus smallest. Select those same things, close the parenthesis. There's my range. Standard deviation. Equals. On Excel, it's stdev.s. If you need help remembering this, on page 371, they talk about finding the range and the sample standard deviation in your book, so you can see what those functions are called there. Or you can watch the video where I talk about doing this. Why is my standard deviation here different than the one I have typed over here? This is 7.36.
Because the one where there's remember?
Yep. So other things we might want to find is median. Equals, there's a median function. Mode. Now mode is the one that occurs the most often. What if there isn't one that occurs the most often? What do you do? I tried to find mode and it didn't like it. Because there's nothing that occurs more than once. Sometimes there is no mode. And then mid-range. Mid-range is, I'm gonna have to kind of do this by hand. I don't think there's a mid-range function on Excel. So I'm gonna take, remember for mid-range it was smallest plus biggest divided by 2. So I'm gonna do smallest, which is the minimum, plus biggest, which is maximum. I'm going to put parentheses around that whole thing, divided by 2. There is another term. It talks about it. on page 372, the coefficient of variation, which has another name that means exactly the same thing, relative standard deviation. That is another thing that you can use to talk about how spread out your data is. We're not gonna do that today, but just so you know, there's another one. It takes the standard deviation and you divide it by the mean. And it talks about how spread out your data is. Let's try all this same stuff. Do you want to see Excel again? I kind of feel like that's kind of our most difficult component. Okay, let's find all those things for the second group of dogs. So I'm going to plug in
And this is what we'll have to do on our Excel. And this is the one there's no video on. No.
Well, there is a video, but it's not called a help video.
Oh.
It's just in your regular set of videos.
As long as this is like exactly what we're doing, I think that we can.
So, this is not called an optional video. I think that's the difference. Normally, the Excel videos, I'm like, here's an optional video. But I didn't call this optional. Mean, median, mode, mid-range, range, standard deviation on Excel. Here is that video. Okay, so for the second set of dogs, if I want to find the mean, equals, it's called average, and I select all the data that I want to find the mean of, close my parentheses. If I want to find the range, that's biggest minus smallest. So equals biggest, which is max, the maximum data point, close my parentheses, minus the minimum data points, MIN. That's range. Standard deviation. It's called stdiv.s. Standard deviation sample. There's a median function. That one's pretty straightforward. It's just spelled median. There's a mode function. However, keep in mind that your data might not have a mode. If nothing is repeated or everything's repeated, if there's nothing that wins, then it's not going to like it. So you need to look more closely and say, oh, it doesn't have one. Mid-range. Smallest plus biggest divided by 2. Smallest is minimum. Close my parentheses. Plus biggest is maximum. Better if you guys had laptops or computers in here and you can be practicing this. Put parentheses around the whole thing, divided by 2. So, just one more time, a reminder. Your homework checklist talks about showing progress on a practice test. That is not yet available, so don't worry about that. We have a statistics spreadsheet project. Why don't we just open that up real quick? There's 2 sheets. The second sheet, you're going to be doing the kind of stuff that we did. Mean, median, minimum, maximum, mid-range, standard deviation. You're going to be doing all of that, just like we did. You're also going to sort your data. Have you watched a video on sorting data? I wonder why I didn't give that to you again. I'll put that in there. You'll need that. But what may be confusing to you is that on sheet 1, I just want you to play around with some numbers so you get a better sense of how mean, median, mode, all these things work. Just more of an intuition. So what you're going to do is follow these directions. Change the input values in the light orange boxes until you get a mean of 25. So I've got numbers in there. 1, 2, 3, 4, 5, 6. And I've already put the formulas in for you. The mean is 3.5. You want to get a mean of 25. So obviously you need bigger numbers. So I could put in 100. Oh, enable editing. Put in 100. Oh look, that took the mean up to 20. So I need some more big numbers if I want to get it to 25. Oh dear. So this, because of the size of my screen, it was not showing this bottom row. It was saying, until you get a mean of 25 and I had to pull that down in order to be able to see it. Beware. I want a mean of 25. I bet this one's that way too. Poop. That's confusing. So in addition to fiddling around with the numbers until you get a mean of 25, you also are trying to aim at a range goal. So you can't just put in 25 for all 6 values. That would give you the mean, but it wouldn't give you the range you need. So you'll have to kind of spread them out until you get the range you want. Down here, you're messing with it until you get the mean you want and the standard deviation that you want. So you're changing these input values to try to hit those goals. Down here, you are going to replace only the one that is shaded. And then you're going to look at what happens to the numbers. I've recorded the original numbers here. When you change this number, these things are going to change. So then you're supposed to say, oh, which one changed the most? Did the mean change the most? Or the median change the most? Or the mid-range change the most? Once you put a 7 here, change the 100 to a 7. Which one changed the most from the way it was before? Here, when I change this to a 7, which one changes the most? Here's what they were originally. Any questions? You guys are just ready to go out in that freezing drizzle. Woo! It's gonna be so great.
Dude, is it like sleepy?
I don't know. It
I
sounds
thought
loud.
it was you earlier. That's when I looked back and was like, what is she doing? It was definitely sleep. Yeah.
Oh yeah, it's bouncing off the windowsill.
It's already snowing in Warrensburg. Dude, I'm not even gonna lie. I pulled off my shirt today and